No.
Okay.
Okay.
There are here, as you can see here, that there are two different indentation tester, and this is the Rockwell tester. This is the Vickers tester, and I'll introduce you about the Rockwell first. So for the Rockwell tester, the first step is to turn the power on. And so the power switch is here on the back side. It's about
Okay,
here.
back side.
It's not easy to see from this side because you can see where it is. It's about here. You will see a switch here and then turn it on.
Alright.
And you can see here that it's on. And then we can start to prepare the test. First, this is the specimen, and you can see here that for the specimen, some requirement for the specimen that you should pay attention to. The first one is that on the surface of the specimen, please do not have too many scratches. It's it's because, as you can see here, that this is the indentation mark. It's very small, and if the scratches is something like this, the scratches is almost the same dimension of the indentation mark, which will make your indentation process to have an incorrect value. So to make the surface to be smoother. Okay, and this is first requirement. Second, uh, supposedly you want to indent on this surface, and the 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 surface, the top surface and the bottom surface should be in parallel, because any inclination will make the value to be incorrect.
Any
Got it?
what?
Any inclination, I mean,
Inclination.
not parallel with some kind of angle,
Okay.
and this will make your it can also be indented. I mean, be tested the hardness, but however, your value will be incorrect, and you won't know because this machine, this tester will not assure you that this surface is parallel. You should assure yourself. Okay, so after you finish preparing this one, and then of course the first stage is to make sure that the space is large enough to let your specimen to be put here. And please watch out, as you can see here, that there are three indentation marks here already, and try to make sure that your indentation is not too close. Okay, because if too close, and then you cannot get the correct value. Generally, it's at least 3 times.
Not too close to the previous indentation.
Yes, you're right. If it's too close, for example, if just next to the hole here,
Yeah.
and then you will get a value
Not accurate.
which is influenced by the previous
Yeah.
indentation. So generally, to make the space to be at least from empirical knowledge, at least 3 times large, far
Okay.
away
Far away
than
from the size of the previous.
than the 3 times of the diameter of the
Yeah.
indentation mark. Okay, since it's very wide, so we can pick any place that is far away from the previous indentation. Supposedly we pick over here, and now it's going to start. Assume that is parallel, and then it's smooth enough, and then we may start the indentation. And now we will move the stage upwards or downwards. And when you rotate counterclockwise, if you use your right hand, it should be upward. But however, this one is just on the opposite side. If you move this way, is lowering down. And to make it higher, upward, clockwise, yes. And you can make it faster before it's going to it be in touch, and now it's going to be in touch. Before be in touch, we have to make sure another thing, which is the scale. As I told you during the class that there are a lot of different scale for the Rockwell test. For example, if we switch this, and this is C scale, and then I press it, G, K, P, V, and return to C. For most uh, for most steel, C scale is applicable. So we choose HRC. This is first one to choose the suitable scale. And then next we have to set the correct load for C scale, because different scale has different loading. Okay, and look at this list. There's a table here, and the first column is the scale symbol. We have B, C, A, D, blah blah blah, and then this is the first one. Then second is the type of indenter. Uh, Basically, since most of the case we use the C scale, so it's a diamond cone. For the C scale, you should use a diamond cone. So if it's not a diamond cone, then you will get incorrect value. And then the third column, which is the load in kilos. Okay, so now we have to apply 150 kilo as is listed. So we have to set 150 for the test. It's here, but not here. And we can change to different
Load.
load.
Okay.
Okay, and then to pick 150 for this test, because now we are in the C scale. Okay, so to select by this knob. And when the correct scale and the correct load has been set, and then we start to make it in contact and apply the load now. Okay, so later on when I when I lift the stage a little bit by a little bit, little by little, and then you will see that the value will be increasing. And there's an energy bar here, and this light will move toward this way until the set. When the set light is on, and then stop moving, and the test will start automatically. Okay?
Turn green.
Hmm?
The satellite turn green.
Okay, and then let's start. Now it's going to be in contact, so let's move. Let's move very slowly. Okay, you will see here that the value is increasing. And later on, the energy bar will start moving.
Okay.
Okay. And it's the start light is on, and now is testing itself. Okay, so the value is shown here automatically. And the last step is to lower down the stage and then to remove the specimen. And please watch out. I suggest you to push a little bit the specimen because sometimes the indenter and because the indenter is was indenting, and then sometimes when you pull it, which means that you push it lower, oh, and then sometimes it'll stick each other. So if that is the case, when the sticking has been released, it dropped, and it's not good for the indenter because indenter is very fragile. Okay, so to push it a little bit. Now I'll show you the incorrect way. Supposedly we don't push it, just to lower down. Okay, and you will see that it'll drop, it'll stick and drop. So now we are going to lower down, so this way. Please see here a clearance between the stage and the specimen. Which means that they stick each other. And then when you keep lowering down, you can see the clearance more and more. Yeah, but it's incorrect because later on it'll drop. For this one, it didn't drop. For the previous, yes, it's not good.
Each stick, right?
Yeah, they will stick each other. Unless the specimen is very brittle. If that is the case, it won't stick
It won't stick.
each other. Otherwise, most of the case will stick. But as you can see here that during the sticking process, so it'll drop accidentally, or I mean, if that is the case, and then the indenter sometimes it will have some bad influence on the indenter, so it's not good. Here, as I told you that what I told you for this one is incorrect. So to hold it, don't be too hard. Only a very small light force applied, and then to lower down. Of course, now it's already being separated. You can lower it quickly and then remove the specimen. And that is the test.
So,
Any question?
So you light force push and then slowly
Just
move it down.
the force is just
Just hold down.
just hold it,
Okay,
and
hold it.
then to make it not
No stick.
be suspended.
Yeah.
Just to make sure that it's in contact of the stage, and that's enough. So this is a very gentle, mild force.
Okay.
I wanted to ask, when you got the result, there was a sign here. So did that mean it's negative 9.5, right?
Basically, it will not be a negative. And
So it
for
means
this
that the
one,
error?
Absolute value.
this very very good for that question. Basically, you will have a positive value. for this one, it's because this indenter has some kind of damage,
Okay.
and it's very
So it's an
expensive.
error. Okay.
So it's not repaired. But however, all I want you to know is about the process for the testing.
Okay.
Okay?
Yes. So it's about a process, but also when I say we do the practical next week, and then we have the negative in our results, should we input the negative or?
Generally, you won't get a negative value.
Okay.
And it may comes from some reason. First, the surface, as you can see, the surface has some